nuclear magnetic resonance, NMR. This is for the instrument of the NMR spectroscopy. The spectroscopy is used to find out the how many carbon present in your molecule and how many hydrogen present in your compound. We can easily find out the structure in the solution states. So this is for the NMR. The interaction between the nuclei and the radio frequency of radiation is called as a nuclear magnetic resonance. So these are nuclei of certain atoms or molecule consist to the spin. So these options of external magnetic field, the spin states of the nuclei are degenerate, the possessed to equal the energy level. In the presence of the external magnetic field, degeneracy is removed and the separate the energies level are possible. This is for the fundamental concept. What is the selection rule? In case of odd, mass number is odd, atomic number is even, NMR is active, and then mass number is odd, atomic number is odd. So that is NMR, nuclear spin is I is equal to of 3/2, 5/2. So NMR is active. Even is NMR inactive, even odd is NMR inactive. So this is for the selection rule. The instrumentation of NMR spectroscopy. So here you see this magnet. So if the magnet is increasing for 300, 400, 500, 600, 900 megahertz, the compound resolution will be increased. So you take this compound in this magnetic region, magnetic field, and then additionally we can give the radio frequency transmitter. So this is for detection, this is for observation. We can take this printer. So this is for the instrumentation. So here the sample preparation. If we prepare some sample for using the solvent, for example, without hydrogen the solvent, for example CdCl3 and DMSO. So this type of solvent is options of hydrogen. We can use this solvent. So suddenly the spinning is there. So magnet is north and south. So this is for in case of our molecule having the spinning. The proton which is the right amount to energy can be observed. Case of the spinning proton is flip. For example, alpha state to beta state. The value for energy for h nu is equal to delta E. I means B naught is give the plus of alpha state and minus of is beta state. So this is for the spin energy states. Alpha state to excited to beta state. So suddenly the spin relaxation and spin lattice will be there. So we can collect the signal easily. So this is the principles of the NMR. So if the molecule, if the nuclei have the no external magnetic field, spin of the nuclei and its generation of magnetic field without an external magnetic field, the nuclear spin or the random in direction. But the external magnetic field B naught is present, the nuclei align themselves to in the aligned with the field of the external magnetic field in case of upside or downside. So this is for the aligned, this is for the opposing. So there are with external magnetic field is there. Another, so we can represent the magnetic movement of our nuclei using this single arrow. So this is for energy. Okay, we can give the external magnetic energy. So suddenly we can meet this here. This is for shielding, and then this is for the de-shielding. Aligned and opposed these ways. So case of spin is off is B naught external magnetic field given to nucleus with spin lower energy generation to magnetic field, the direction of the external magnetic field. So energy gap of the corresponding to radio frequency, and then it is a nuclear with the spin higher energy generate magnetic field opposed to direct of external magnetic field. So this is for the nucleic are electrically charged and may have to spin the cause with the behave like the magnetic. So another in this type of NMR spectroscopy, the proton NMR spectroscopy, C13 NMR spectroscopy, P31 and silicon 29 NMR spectroscopy. Another Fourier transfer NMR is solid state NMR, etc. We can easily this type of molecule we can find out this solid state one. What is chemical shift? The shielding and de-shielding we can discuss there. The field required to hydrogen to resonance, the verify the slight with the chemical environment of the hydrogen. So record the difference between the hydrogen of the sample and it is a TMS or tetramethylsilane is standard reference. Why we can use the TMS? It is a TMS chemically environmentally same. It is we get this single peak So this what is chemical shift? Delta is observed the position of the peak heads and operating the frequency in the instrument. Delta in 10 to the power minus 6. So this is for the chemical shift. There are the chemical shift values upfield and downfield. So upfield is a shielding and downfield the de-shielding field. So upfield is 0 to 5 and above the 5 to 10 is downfield. So in case of alkane, alkene or some other halogen groups present in the upfield, and also it is downfield is go to keto groups, some other aromatic groups appeared in downfield. Another chemical shift. So this is for the region. The proton number is observed in 0 to 10 ppm parts per million, and then it is carbon 13 NMR spectroscopy is 0 to 200 ppm. So ppm here is a parts per million. So why it's a carbon having the 0 to 10? Because of the proton is 100% natural abundance. So you take minimum 52 seconds in spectrum scanning time. So suddenly we collect the how many proton present in your molecule. If the proton is appeared in 0 to 1, it is alkane, and 1 to 2 is alkyne, and then 2 to 3 are 3 to 4 is a halogen group in case present. For methoxy group, some other halogen group is present. Appeared in halogen protons is appeared in 3 to 4, and 5 to 6 is appeared in this carbon-carbon double bond in case of any carbon-carbon double bond having the proton, that is appeared in 6 to 5, and then 7 to 8 is aromatic CH protons appeared in this region. Above the 9 to 10 is appeared in aldehyde or acid proton is appeared in this thing. Delta is equal to downfield is de-shielding region. And the same things, it is a carbon 13 is 0 to 200 ppm the parts per million. It's appeared in 0 to 20 or 0 to 30 is alkane carbon is appeared, and then 30 to 50 or 60 is halogen carbon is appeared, and is another way the 100 to 150 is appeared in carbon-carbon triple bond or aromatic carbon appeared in the region. Aromatic carbon is appeared in this region. Above the 150 to 200 is aldehyde, ketone, acids, carbon is appeared in this region. So this is the chemical shift of value. So here you see one example for the ethanol spectrum. Ethanol formula is CH3, CH2, OH. There are the three environmental is possible. Here the n+1 rule is possible. One is A is neighboring, we choose the neighboring group, and CH2 is neighboring group. Here the electromagnetic group is that this is not coupled with the neighbor. So then A, B, C here. So here the concept of CH3 gave the triplet because of CH3 neighbor group CH2. So n+1 is a triplet is appear, and then CH2's neighbor group is 3 and appeared in quadret groups, and OH is appeared in singlet because of OH group is not coupled with a neighbor because of electromagnetic group is present. So already we know that the TM is tetramethylsilane is magnetically equivalent, so it is appeared in 0. So this is for standard. So here the using the Pascal rule for singlet is 1, doublet, triplet, quadret, quintet, sextet, subset. There are the above the quadret we are talking about the multiplets. So this is for the ethanol spectrum. Another one spectrum is proton number spectrum, ethyl benzene. Here see the methyl group is appeared in 1 to 2 region, and then it is a CH2 group is appeared in 2 to 3, and then aromatic group is appeared in 6 to 7 region. So this is for the proton number spectroscopy of ethyl benzene. So another one important application for the medicinal field, MRI scan is also it is advantages of the NMR spectroscopy. We can easily, in case of insured in our head, we can easily find out the image. So using this advanced spectrum for MRI scan. So this is fundamental concept of the NMR spectroscopy. In our research, based on this spectroscopy, we can using this spectroscopy we can easily find out some unknown compound. So this is for my research for design, synthesis, characterization, confirmation, biological investigation of NSL piperidine 4,1. So I prepared the 3-methylbutanol and to paramethoxybenzaldehyde. I prepared the piperidine 4,1, and using the derivative of the more than 4 compounds for phenyl carbamyl, acetyl or chloroacetyl diamorphin compound. So first we can easily find out this parent compound having that there are the two functional group is there. It is a keto group is appeared in 1700 centimeter minus 1 and stretching vibration, and then 3300 stretching vibration is appeared in NH stretching vibration. So I can easily find out this my parent is having the two functional group, and then aromatic region is appeared in this region. So this is for fingerprint region. So another one is derivative. So phenyl carbon compound. So I am substituted here the NH. NH is disappear, and in this present new NH is appeared. So that is a new NH is 3301 centimeter minus 1, and then it is for 1600 the 1700 additional carbonyl stretching vibrations appeared in two way. This is for we can easily find out there are the two carbonyl group, and NH group is easily find out this derivative compound. So another one is mass spectroscopy. So I can find out my molecular weight is m by z is 458. So and then so you can easily find out the molecular spectroscopy. Another one is this is for the derivative compound of phenyl carbonyl derivative compound of proton NMR spectroscopy. We can easily find out the doublet of doublet, triplet of doublet, some other values for the 0 to 9. So I can find out the compound. So like this. So this is for the 2D NMR spectroscopy. HH COSI, the hydrogen correlation, which hydrogen is correlated with another carbon. So I can easily find out this molecule in using this COSI spectra. So this is for the C13 NMR spectra. So how many carbon present in my compound? So I can easily find out this region. For here the two methyl groups is there, another one is C5C2, some other methoxy group is there, the range of 40 to 6 ppm, and then is aromatic region is 122 and 140, and then also 160 another one carbon double bond, and then keto group is C4 is appeared in more than 200. So I can easily find out my compound. So this is for depth NMR spectroscopy. In case of hard carbon, even carbon is there, we can easily find out the diagonal for up and down. So I have only for CH2 group is C5. So this signal for identified this group. Another group is appear in upside. So this is for the add carbon. So this is for CH COSI, carbon and hydrogen correlation spectroscopy. So in case of we synthesized organic compound, definitely carbon and hydrogen is there. So the carbon, which carbon is correlated with which hydrogen, and ECD you can easily find out this using this spectroscopy. So this is some other values for proton NMR and C13 NMR spectra for chemical shift values, and then this is for the coupling constant of the values. We can easily calculate with proton and C13 NMR spectroscopy. And then it is C13 NMR chemical shift values or DC shielding or deshielding. We can easily find out this spectrum. So another way is solid state chemistry. In case of we are doing in the solid state chemistry research, so same things I prepare I grow this on compound for the new class of phenol material. So this is also it is isopropyl 1541. So you see these crystals, we collect the big crystals. So I take this UV visible spectroscopy. I will here the 200 to 400 region is UV region. I got only 5 pi star and pi star transition only. So our compound is there is no any color. So here the 400 to 800 there is no any absorption in the entire region. So I can conclude my compound is colorless and is very transparency. Using this UV visible spectroscopy. Then it is a Fourier transfer FTIR spectroscopy. I can easily find out the NH stretching vibration and keto vibration, and then some other aromatic group is easily find out them. Another way is proton NMR spectroscopy, and then it is so in case we are in research or we are in project, we are involved in some other we synthesize some other compound, some other new compound. You can take this UV visible NMR some other spectroscopy. You can easily find out what are the present in your molecule, what are the functional group is present, what are the bonding is there. So finally you find out the what type of compound you are collected. So this is for the application in chemistry and physics and medical as well as the pharmaceutical field. So let's see Another one is a conclusion. The spectroscopy is the physical and analytical chemistry because of atom molecule have the unique spectra. As a result of this spectra can be used to detect the identify the quantified information about the atoms or molecules. Spectroscopy is also used to astronomy and the remote sensing and as well as the space research. So this is the reason it is spectroscopy is presently very rich development in nowadays. So this is my conclusion. Thank you.